Okay, so if the population needs to remain constant, let's see what the population density of deer is for each square mile. Well, when we find the number of deer per 1 square mile, what is this called again? The unit rate. So I went ahead and wrote that down. So I actually gave you a hint. So sorry about that in advance. But we have definitely debriefed our plan now. We've talked it out. We are now going to set up our table with values because now I know we are trying to find out the number of deer per square mile. So in other words, we want to know if the deer are proportional to the square mile. So let's write that note as well. Deer proportional to square miles, so to the land. Okay, so which one of these is our independent variable? Well, I know that the square miles is the area of the land that affects how many deer can live there. So that is going to be our independent. What about our dependent variable? Well, besides process of elimination, the deer are going to be the ones that depend on the square miles because if the land increases in size, then more deer can live there. But if the land decreases in size, then the deer population also needs to decrease. So y depends on x. So now that I know where the x variables are and the y variables are, I'm going to go ahead and put that into our table. So square miles and number of deer. Okay, so now that we have the word problem or the table set up, let's put the numbers in from the word problem. So I see 144 deer live in a 16 square mile area, 117 deer live in a 13 square area, and 216 deer live in a 24 square mile area. Okay, so now we need to look at the relationship between the square miles and the number of deer in the table below. So how do we know if the relationship is proportional? Well, we said that the square miles and the deer would need to increase and decrease at the same rate. So how do we find that rate again? I remember that we divide the deer by the square miles. So deer divided by miles squared. I don't like the way that looks. Let's do square miles. And so that is going to determine what the unit rate is or the number of deer per square mile. So I'm going to pick whatever pair I want. I like the 144 and the 16. So I know there's 144 deer, so that goes on top. For 16 square miles, so that goes on the bottom. So I'm not going to draw 144 deer, but we are definitely dividing it among the 16 square miles. And so I know that 16 is the divisor and 144 is the dividend. So we placed our seats, and I know that 16 goes into 14 0 times, but I'm not quite sure of how many times 16 goes into 144. And so instead of guessing and checking, which I know a lot of us like to do, and if that's a strength, then great, continue doing it. But for me, I don't like wasting time on guessing and checking when I keep, guessing wrong and then have to try something else. So I'm going to make a top-bottom chart that you have seen before in 6th grade. Typically, you would go all the way to 9. And so what we're going to do is count by 16s. So 16, and then add another 16, and then add another. Okay, so I've continued the table on my own, and now we are going to see how many times we can fit 16 into 144 without going over. So I'm just going to move my pen down the table until I hit 144, but do not go over it. So I actually end up hitting 144 exactly. And so the top bottom chart tells me, please excuse me, that the top number is 9. So 16 goes in 144 9 times. And the bottom number is 144, which equals 0. Great, so what does this 9 mean? Well, it is telling us that there are exactly 9 deer per square mile. So 9 deer for every 1 square mile. So remember, when we hear the word per or each or every, we know that that means 1. All right, so now that we have our answer, we've been calling this value the constant multiplier and the unit rate in previous lessons. So today we are learning a third name that we can call this value, and that is called, it's actually very lengthy, so I'm going to write this down, the constant of proportionality. Okay, so the constant of proportionality. We've been calling it unit rate, we've been calling it constant multiplier, and now we have a third term. Well, if we broke this vocabulary word up, it actually makes sense because it helps determine a proportional relationship between two values. So we know that this proportional relationship is going by 9 deer every 1 square mile. And since it is changing at a constant rate, right, we have the constant of proportionality. So we know that we can also call 9 not just unit rate and not just constant multiplier, but also the constant of proportionality. So we could actually add this unit rate or this constant of proportionality to the table because we know that 1 square mile equals 9 deer. And so if we wanted to just double check if this actually does mean the same thing, if we use our constant multiplier, right? Remember, we can call this our constant multiplier. Is 1 times 9, 9? Yep. So 9 is also our constant multiplier. It's also our unit rate, right? When we compare it to 1 of something. And it is also our constant that keeps our tables proportional, constant of proportionality. Alrighty. So we will still be using this term and all the other terms as well. And we also want to make note that we found the constant of proportionality the exact same way that we have found the unit rate in previous lessons. Remember, we divided the deer and the square miles. We divided the y value over the x value. So we're going to write a formal equation for it. So every single time I am asked to find the constant of proportionality, I know how to do that. So I know I'm going to divide y over x. All right, now this is going to seem a little silly, but we use a variable for the constant of proportionality. Remember, a variable is a letter that we use to substitute and represent a number that is in its place, and that is k. Don't ask me why, right? Constant doesn't start with a k, and yet we know that k is the constant of proportionality. That's the variable we use every single time to represent that number. All right. So we still haven't answered the actual question. So let's go back and look at it since we haven't answered it fully. It says that should the conservationist need to be worried? So we know that there are 9 deer for every square mile in each of the ratios that they gave us. So then would they have to be worried? Is the rate changing at all in one area or the other? No. So I'm going to write a sentence to say that. So no, conservationists don't have to be worried. Conservationists don't need to be worried because the deer are actually increasing and decreasing at a constant rate. Deer, or we could say, are changing at a constant rate. Let's be more specific. Of 9 deer per square mile. Awesome job, guys.